In this tutorial, I want to quickly discuss with you the different hybridization states of carbon atoms. And just as a quick revision, we know that the relevant electron configuration for carbon is we have 2 electrons in the s orbital, and I illustrate that with these 2 arrows, and then we have 3 p orbitals, 1, 2, 3, and we have basically 1 electron in p1 and 1 electron in p2 and no electrons in p3. So that's basically the situation that we are dealing with. And what we can do is, of course, we can mix these orbitals in the case of carbon and some other atoms. So what we can do is we can basically shift the electrons, and we can make all these orbitals more or less the same energy. And of course, they are no longer distinct S and P. They are now a mixture. And we could distribute our electrons into these 4 orbitals that we have. So it's this sp mixture that we have, just basically a blend of the s and the p orbitals. And this also means that all 4 orbitals have similar or the same energy. Same energy, and that is why why carbon in this state can form 4 bonds, and all bonds are equivalent. And we indicate what we have done here is we basically say we mixed the S with the P1 plus P2 plus P3, and then distributed our electrons equally, and this is also sometimes abbreviated as S, and we used all 3 p orbitals, so sp3. And the relevant carbon molecule would basically look like something like this. All 4 bonds are exactly equivalent, and there's no difference between them. So you have individual single bonds on this carbon. Now we can also do a different distribution. We can actually say, well, instead of mixing it with all 3, mixing the S with all 3, what I do is I just mix it with 2 P's. So basically I take P1, P2 and P3, and I say, okay, I don't touch P1. P1 stays as it is. But I mix my S plus P2 plus P3 orbital. And P2 also has an electron. And what I then get is basically this situation. Here is my mix. And I've got 3 electrons in that. Plus, I've got my P1 orbital, that is the one that I haven't touched. So, what this means is I have 3 bonds here. Oh, that's interesting. I don't know where this comes from. I've got 3 bonds of the same energy, same energy, and one bond with a different energy. And what have I done here? I've mixed the S with 2p orbitals, so I abbreviate that as sp2. And what it would look like is basically it would be a carbon with 3 equivalent bonds. So these are the 3 sp2 bonds. sp2, 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 and then it also, and I use a different color, it also has an additional pure p bond, and I indicate that here with red. So that is the remaining p bond. Or if you want to make life easy for yourself, if your carbon has one double bond, the carbon itself is sp2 hybridized. And the best way to arrange 3 interactions is just simply like a planar flat configuration. The last bit that we can have is we draw our S again. We have our 3p orbitals. So P1, P2, P3, and P1 and P2 have electrons in it, and I abbreviate that again. And what we do now is we just say, oh, we are not going to touch P1 or P2, but we just mix S with S plus our P3 orbital. So what do we get? We get two orbitals, that's our mix, that's the S plus P3, and we put in an electron in each one of them. Plus, we also have P1 and P2 left, and they are at a different energy level. So we basically have 2 with same energy, and we have 2p. They also have the same energy, but they are very different to the one that I've just showed before, same energy. So we would call this a mixture of sp, because we just mixed our S with one of the p. In terms of structure, what this would look like is we have 2 equivalent bonds here, that's the S. So we have a carbon that looks like that. These are the sp bond, sp here. And now we have also 2 p bonds. It could be arranged either like that and that, so that would be P1 and P2, or they can be on the same side. So it could also be that we have, these are our sp2, we could have also on the same side like this. So in both cases our carbon is sp hybridized, and the way you can arrange these 2 sp bonds is just simply in a linear molecule. So in both cases the configuration would be linear. So in this case you have 2 double bonds, for sp, or you can have 1 triple bond. and both would be SP. So I hope this makes sense, and thank you for watching.